So I'll hand it off to you, Natalie.
Great, thank you so much, Anna, and thanks all of you for joining for our next session. You are now at Resources for Justice40, Equitable Deep Decarbonization and Key Gaps. And I'm going to introduce our 4 illustrious panelists. But for your knowledge, I am also a colleague of Anna at Lawrence Berkeley Lab and the Justice40 Fellow at the DOE. So been working on metrics and data for the past year. So we are going to kind of dive into implementation for some of these frameworks that Anna has introduced and other conceptual frameworks of equitable deep decarbonization to really try to identify data and resources to support this process. So today we have 4 speakers with us. Susan Anenberg is an associate professor of environmental and occupational health and of global health at the George Washington University Milken Institute of Public Health. She's also the director of the GW Climate and Health Institute. She currently leads a NASA-funded team called Satellite Data for Environmental Justice. So that's going to be fun to learn about. Next up, we have Bonnie Keeler, an associate professor at the Humphrey School of Public Affairs at University of Minnesota. And she's also the co-director for the Center for Science, Technology, and Environmental Policy. Bonnie is a newly appointed member of the EPA's Board of Scientific Counselors Subcommittee on Social and Community Science as well. Erin Mayfield comes to us from Dartmouth, where she's an assistant professor of sustainable systems engineering and public policy. She also directs the Sustainable Transitions Lab and Clinic. And her research really focuses on co-producing computational decision support tools to integrate equity objectives into energy systems modeling, and providing an example of what Anna just introduced to help inform policymaking and infrastructure planning. And last but not least, we have Ishan Nath, an economist who works with the Climate Impact Lab, which, if you recall, were some of the really cool results Anna was just presenting. He's also a postdoc right now at the Econ department in Princeton. So a quick reminder, everybody, we're just a few minutes behind schedule. So we're gonna keep our panelists to 10 minutes each, and then we have a Q&A. We'll have about 20 minutes for that at the end. And please use the Q&A chat function. We do not have a way for participants to raise your hands or talk due to the number of folks on the call. But I'll be monitoring the Q&A, so I'll present your questions to the panelists at the end. And last but not least, we've got a Google Doc here. I'll just drop it in the chat where you can send kind of resources, ideas, additional questions that you might have. So we will go ahead and kick it off with Susan Anenberg.
Excellent. Thank you so much. It is a pleasure to be here today with you, and I'm just going to jump right in because we only have 10 minutes. I'll be talking about using satellite data to address environmental injustice. And it's just really interesting, you know, as Justice40 is coming alive, we have this rapid acceleration in data from novel sources. And so it's no longer the case that we're as data limited as we used to be. And we have some emerging sources of information that we can use to identify overburdened communities and track environmental injustices over time. And that's going to be the focus of what I talk about today. But I want to start with how excited I am that this conference is linking decarbonization with environmental equality, with health, and with equity throughout. These are topics that are often considered separately. And of course, we all know that they're highly interlinked, as all of the panelists that have come before me have articulated. And I just want to throw out there an additional, data point that people are recognizing these interlinkages. This is just one example of some research that some master's students and I did looking at climate action plans that have been developed by 27 C40 member cities. And a lot of these were located in the United States. And we looked at whether or not these climate action plans consider equity and exposure to environmental quality indicators, whether they consider the health effects of climate change or the health co-benefits of mitigating climate change. And to our surprise, all the cities, every single one of them considered every single one of these 4 indicators. And you can see the split between the references to equity versus environmental exposures versus health. And on the right-hand side here, I wanted to dig a little deeper and show you what environmental indicators these cities are concerned with, or highlighting at least in their climate action plans. About a quarter of them were highlighting physical activity, 23%, another quarter about highlighted green space. We have about 20% that highlighted disasters, 12% talked about air quality, 16% talked about heat, with fewer references to vector-borne disease and waterborne disease. Interestingly, about 3/4 of this pie here, the sections pertaining to green space, air quality, heat, disasters, can all be informed by space-based observations. And so the fact that we have Earth observing satellites at a time that this is coming to light, these interlinks between decarbonization, environmental quality, health, and equity, is a really nice confluence of events, because we actually have observational data that can inform this. I'm going to focus the rest of my talk mostly on air quality because that's my particular specialty, but I'm going to zoom back out at the end. We have ground monitors around the world, and that is what the world has relied on historically to provide information about air pollution. This is a map on the left-hand side here of where PM 2.5 monitors are located. And of course, you can see that there's large swaths of the world, Africa, Latin America, Middle East, and Asia, that have very few monitors. It looks like we have a lot in the United States, but of course, the dots here are out of, are not sized appropriately. So let's zoom in on a city, the one that I happen to be sitting in right now, Washington, DC, on the right-hand side here. And we have 4 monitors for PM 2.5 within the District of Columbia. And so this is not sufficient to be able to provide information on a neighborhood scale to know who is being overburdened by air pollution and how that is changing over time. Luckily, we do have now space-based observations of air quality. So we can link together satellite observations with what we know about how the atmosphere works and calculate ground level surface concentrations of air pollutants. The benefit of doing that is that we have full geographic coverage. We have now achieved relatively high spatial resolution with satellite data, and we actually are building somewhat of a long-term temporal record at this point with our Earth observing satellites. And so this is a map that we produced with some partners at NASA, showing how the map of PM 2.5 related mortality looks across the city of Washington, DC. And for those of you who live in DC or have or know it well, you can see that this map lines up pretty much exactly like the map of racial segregation in the city, with higher PM 2.5 related mortality rates in portions of the city that have higher proportions of Black residents. This was picked up by an Instagram account, Washingtonian Probs. Maybe some of you follow it and have seen this before. And I know we're not supposed to look at the comments on social media of our own work, but one day I decided to do that. And the most common comment received when this Instagram account posted this was, duh. So, people know this. I think people know that air pollution is inequitably distributed, and yet we still are lacking in the data to provide evidence on which specific neighborhoods are being inequitably overburdened with air pollution. I'm going to talk now about another air pollutant, nitrogen dioxide. PM 2.5 is the biggest killer. Nitrogen dioxide, though, is linked with pediatric asthma incidence. That's new development of asthma among children. And we know that not only is NO2 inequitably distributed, but children's asthma is inequitably distributed, with children of color experiencing much higher rates of asthma compared with non-Hispanic white children across the country. NO2 is somewhat of a convenient pollutant to look at from the perspective of mapping air pollution and justice. It is a marker of fossil fuel combustion. In cities, that largely comes from traffic-related air pollution, but also from point sources like electricity generation. It's also very easily observable from space. We have Earth observing satellites right now flying around the Earth, measuring nitrogen dioxide. And we can create a map like this of surface level nitrogen dioxide at very high resolution and get block group level NO2 that can be directly integrated into EJ mapping tools like EJ Screen and related with demographic variables. I want to provide a couple examples of what we can see with space-based observations of nitrogen dioxide, because frankly, I am just floored by the capabilities, and I did not expect to see this type of result when we first started looking into this. But back in the early stages of the pandemic, we were all experiencing these lockdowns, and a lot of cars were off the road, and we wondered, could we see disparities in nitrogen dioxide using satellite observations during this lockdown period? And so my colleague Gage Kerr led a study which looked at NO2 concentrations in the least white census tracts across the United States compared with the most white census tracts. And we see that the NO2 concentrations in the least white census tracts were approximately double those of the most white census tracts prior to the COVID lockdowns. During the lockdowns, both these orange dots and the blue dots shifted left, indicating that NO2 dropped. And yet we saw something that was extremely concerning, that during the pandemic, NO2 concentrations in the least white census tracts were still approximately 50% higher than NO2 concentrations in the most white census tracts prior to the pandemic. And so this indicates that these disparities in NO2 pollution were so large prior to the pandemic that the approximately 50% drop in passenger vehicle traffic that we experienced during lockdowns was not enough to erase these disparities. And we see this pattern across most major US cities, and we also saw similar patterns based on education and income levels. This is some work in progress that is showing the temporal trend in these disparities in nitrogen dioxide. And we see that NO2 attributable new asthma cases among children across the United States is dropping for the least white census tracts and the most white census tracts. In fact, it's dropping more for the least white census tracts compared with the most white census tracts. And yet we still see, looking at the line graph on the bottom of this plot here, we still see that the relative disparities are increasing. And so we see widening disparities in NO2 attributable pediatric asthma incidence across the United States. This is all based on the combination of satellite data with what we know about atmospheric dynamics and land use variables. The fact that we are seeing such a huge signal in street level differences in air pollution using satellite data led us to develop a NASA supported team that we call Satellite Data for Environmental Justice. It's part of the NASA Health and Air Quality Applied Sciences team, or HACAST. HACAST itself is a collaborative team that works in partnership with scientists as well as public health and air quality agencies around the world to use NASA data and tools for public benefit. And our Tiger team, Satellite Data for Environmental Justice, has a goal of integrating satellite data into EJ screening and mapping tools. I talked about air quality today. That's my personal focus of my research program, but there's a lot of people involved in this, and they bring a huge amount of expertise, including in heat exposure, in green space, in light at night, and other environmental quality variables that we can see from space. And we're working directly with a range of stakeholders, including national EJ mapping tools, state EJ mapping tools, and non-governmental organizations as well. And what we're trying to do is really bridge this gap, recognizing that some of these EJ mapping tools have data within them that are either lagged behind, several years behind, because it takes a really long time to produce these data sets. A lot of the data are estimates and not observational, or they may be too coarse spatially to capture the neighborhood scale differences that we're seeing, or perhaps they're not fully, they don't have full geospatial coverage. Satellite data can really help to fill these gaps, and we're seeing this, unfold as we speak, evolve as we speak. These are some images that we just produced where we just wondered, we asked ourselves, could we see a signal from space of the higher air pollution levels around the trucking activity surrounding warehousing areas? And you can see that indeed, we can see from space higher NO2 concentrations around the warehousing activity just north of Dulles Airport outside of DC. Similarly, we can see a signal in NO2 pollution along I-95 between DC and Baltimore that allows trucks versus the Baltimore-Washington Parkway, which prohibits trucks. So our goal is to integrate information like this into EJ mapping tools. And I just want to end with one additional piece that we are identifying as a need, and that is in line with the Justice40 initiative. We really want to know who receives the benefits of reducing air pollution. And I would argue that we don't currently have the analytical tools to enable us to do that yet, and this is a huge need. So just as one example, in March, a couple months ago, the EPA released proposed standards to reduce NOx emissions from heavy-duty vehicles, and the EPA in its regulatory impact analysis acknowledged, as you can see on the table on the right-hand side here, that 46% of people of color across the United States are living in areas that have the highest 5% of PM 2.5 concentrations, compared with only 25% of non-Hispanic whites. And yet the regulatory impact analysis was not able to assess who received the benefits of reducing NOx emissions. I will say this proposed rule could dramatically narrow inequities and air pollution health risks, because it would massively reduce nitrogen dioxide pollution, which contributes to, as I mentioned, pediatric asthma. And yet the demographic distribution of the air quality and health benefits are currently unknown because of challenges related to the spatial resolution of our modeling tools, the challenges with getting health data at high enough spatial resolution to understand the vulnerability of the population breathing those air pollution levels, and the historical focus on ozone and PM 2.5, and not nitrogen dioxide, despite the fact that it's the pollutant that is likely the most inequitably distributed in US cities. So we do have some needs for capturing who benefits. And I know that a lot of people on this call are working towards that right now. And finally, if you would like to participate in satellite data for environmental justice, we have open monthly team meetings where we exchange information and build a community of practice about using satellite data for EJ applications. So if you're interested, please reach out to me or GaugeCur. Thank you very much.
Thank you so much, Susan. And you've generated quite a few questions in the chat, so I'll save some of those for our Q&A. And next up, we have Bonnie.
All right, great. I'm going to go ahead and share my screen here. Can you all see the screen or the notes version?
We can see it in presentation mode now. It's great.
Okay. Great. So I'm a faculty member at the Humphrey School of Public Affairs, and I work with Gabe Chan at the Center for Science, Technology, and Environmental Policy. My expertise is primarily in water policy, so I'm coming at that from many years thinking about how do we evaluate the benefits of alternative environmental policies from an equity and from an efficiency lens. So what I'm going to talk about today are some of the insights I've had from evaluating those past policies through a water quality lens, but I think that all the insights are very generalizable to the work that we're talking about today. So I see this as a challenge of trying to reconcile a focus on efficiency and a well-developed policy toolkit that we have for estimating the benefits and costs of alternative rules or regulations, and this new mandate from the Biden administration on modernizing regulatory review, and then the path for achieving Justice40 that we saw in these initial memos, where we now have really clear guidance that we need to fully account for regulatory benefits that are difficult or impossible to quantify, and that we have to take into account regional and distributional consequences of regulations, and then make sure that 40% of those benefits go to disadvantaged communities. So the research questions that really motivate my own work now are thinking about if the methods that we have for policy analysis are really fit to purpose for the kinds of questions that this work demands of us. So I'm going to talk about some of the insights I've learned from thinking about what's the value of environmental improvements based on the existing tools of policy analysis that we've been using over the past several decades. Using that toolkit, what values are captured and what values are underrepresented or missed from that toolkit. And then what are some recommendations and gaps for addressing what I think as the sort of next generation of environmental evaluation of regulatory review. So I have training as an environmental economist. I also have a very interdisciplinary background, so I feel like in some ways I get to be unmoored from discipline in the way that I think about assembling a policy toolkit. But just to level set here, some of the key assumptions that are in economic models and analyses that I think have a big impact on what comes out on the other end are that we are looking for contexts and situations where values can be expressed through a consumer choice model, which means that we're observing people's preferences at the level of the individual, and we're thinking about observing those at the margin. What's the next unit of change, and what's the impact of that change on human well-being? We assume people are rational, that they have full information, which is a really key assumption when we're thinking about environmental analysis. And I know Kate Hausman has done some work on that, and she's in the next panel. And that we assume that people have well-formed preferences, right? They know what they prefer and they'll act on those preferences. And our goal is to maximize net social welfare. And we assume that those gains in welfare, the net gains, can be distributed, and that there's a mechanism to compensate losers and everyone can still be better off. And that this sort of triumph of the technocrats, as Cass Sunstein talks about, has been sort of the dominant frame with which we've evaluated the impacts of environmental policies. But that framework, those assumptions in some ways act as a funnel where what comes out on the other end is influenced by the assumptions that are embedded in some of those models. And so I'm just going to give 3 examples of some of the implications of applying that assumption to environmental and energy policies. And the first is that not all benefits end up being valued. The second is that the preferences of the rich receive more weight than the preferences of the poor, and that historical and social context are not considered in those models and tools. So here's some examples just from a literature review of regulatory impact analyses and economic analyses under the Clean Water Act. And what I want you to pay attention to here is just that you pull these regulatory impact analyses off regs.gov, you look through them, and what you see is lots of evidence where we're missing benefits. You know, we wanted to quantify this, but we couldn't because there was a lack of data. This benefit wasn't monetized. This benefit wasn't quantified. We are unable to quantify this. We're unable to quantify that, right? So what ends up being actually monetized is a very, very narrow subset of the full set of potential benefits of policies, proposed rules, or regulations. So because we're looking for specific types of benefits that we can monitor and model and monetize using that economic toolkit, a lot of the benefits can't be monetized, can't be quantified, and so therefore are left out. We think about preferences that go into these models. So here's a photo of a lovely lakeside house in Minneapolis. We know from many studies that look at the economic benefits of water quality that if you improve the water quality in a water body next to a house, that increases the property values, that through hedonic modeling, we can estimate that increases in water quality, the same thing for air quality, increase property values. But if you think about where those benefits really accrue, it's to people who have the ability to own property, especially beautiful lakeshore homes like this. So, you know, we're already limiting the preferences that you're observing to particular individuals. And in a city like Minneapolis, where we have one of the US greatest disparities in terms of home ownership, about 75% of white families own homes and about 25% of Black families own homes, you can imagine the implications of taking observations based on property values and extrapolating that as a metric of efficiency of where you should invest your water quality dollars or your air quality dollars, and whose preferences are being prioritized in that method. And most of our economic tools are also very blind to the historical context that gave rise to the contemporary distribution of environmental benefits and burdens. So in the top picture is a map looking at the distribution of residential land values in the Twin Cities. And this is tied back to decades of racially restrictive housing covenants, redlining, and very strategic acts on the behalf of developers of finding properties, putting covenants on them, and then advocating for green space, for park investments, for water quality improvements in tandem with those restrictive covenants. And then there's 2 examples here from law review articles that just talk about how even when you have a set of you have a regulatory toolbox that in theory should affect all communities equally, that the existing underlying inequities and how policies are deployed, the resources that communities have to advocate for those policies, potential unintended consequences of navigating between tribal, federal, and state regulations can mean that you'll have vastly different outcomes from the same regulatory toolkit. And those historical contexts are really missing in all of the way that we think about evaluating the benefits and costs of alternative regulations. So a couple of observations from this work. First is that different methods are going to lead to different decisions. So I appreciate the focus of this session on thinking about alternative methodologies. And we're experimenting in my group with all kinds of different approaches of trying to understand the benefits and costs of alternative environmental investments. And that includes traditional non-market valuation work, but also participatory mapping, photo voice work, social media analysis. We're deploying chatbots in some regional parks. We're doing participatory mapping and Q sorts and focus groups. And all of these methods, in retrospect, are giving us very different answers than we would have gotten if we had just looked at that traditional non-market valuation toolkit. Another observation is that the priorities of the bottom-up approach often are very different than the priorities of the top-down approach. So here's a publication from a coalition of environmental justice organizations in the Midwest that looked at their top priorities for different environmental issues. And the top 4 are in orange right there: air quality, food, health, and water. If we were to just sit in our own kind of regulatory space and say, what are the priorities that we want to focus our work on, and where are we going to get the best return on investment, we may not be picking these same priorities, right? So there can be a really disconnect if you ask people what is most important to them versus identifying where is the greatest place to maximize efficiency or gains in net social welfare. The other thing I would mention here is you look at, there's things like housing and land and urban planning that don't necessarily fit into what we think of when we're in it as the environmental community. And that's another important insight in how important it is to do cross-sector work. And then another observation is that community priorities do not always align with research expertise. And I think this should be obvious to most of us, but it really became clear to me in a project that I led several years ago, where we had a really flexible pot of money where we were able to genuinely engage with communities in Minneapolis and St. Paul and ask them, what are the areas where you see the greatest needs for your communities? And we had come in, thought about stuff around the distribution of air quality and water quality and park spending. But what we heard from them is that their research priorities were very different than the ones that we anticipated going in. So what we heard back after years of engagement is that their priorities were about environmental investments without displacement, having affordable housing and quality urban environments, about strategies to level the playing field for meaningful citizen involvement in their communities, questions about power and representation in the institutions that govern how urban green spaces and the urban environment is allocated, and then really understanding the historical and contemporary coupling of infrastructure and privilege. So these required this research team to really pivot the work that we were doing and think about this project from a very different perspective. So given that, I think I'm going to just conclude with a couple of recommendations really briefly, and happy to elaborate on any of these in the Q&A, but the importance of really defining the decision context. And obviously we cannot be paralyzed by getting this right, because we have to act with a lot of urgency. So we cannot necessarily wait until we have perfect information and a perfect process, but at the same time, it's important to step back and think, okay, is the right method for this context tied to what the information is going to be used and who's the audience? So is this study just to raise awareness? Is that our big issue right now? We have to raise awareness about equitable deep decarbonization. Or is it really about we need to develop policies and instruments and payment schemes, and we need the type of time and resources and accuracy requirements in order to do that? Then that requires a different set of methodological approaches. The next is that I'd love to see us do much more in terms of combining disciplinary approaches, policy analysis. We've done some work where we actually present a bunch of different potential policy analytical tools to end users, agency staff, nonprofits, federal government, and ask them, like, what's useful about this? Which of these kinds of metrics would you use, and what purposes do you see them serve in your work? And got some really interesting insights from that. And that I think we can be much more systematic in deciding how we frame our studies, whose values are important, who's the relevant population, and is that toolkit that we have really appropriate for that suite of values. If you're trying to assess cultural values of investments in protecting clean water, I don't think it makes sense to use a hedonic model and estimate property values associated with clean water. The next recommendation is to think about investments in creating community-facing knowledge products. I mentioned that we had a very long community-engaged research project. One of the outcomes of that was an explicit focus on how do we deploy and improve environmental quality without causing gentrification and displacement, which is something that came up in the panel yesterday. And so one of the core products of that work ended up being a community-facing policy toolkit, where we reviewed ways in which communities could advocate for community benefits agreements, inclusionary zoning policies, affordable housing finance. I'm not an expert in housing. We had to marshal a whole bunch of resources to kind of pull this together, but the goal was to really take what the community needed seriously and then marshal the resources of the research university in service to those needs. And that meant very different research products than we initially envisioned. On the right, you see a map where one of my graduate students mapped rent increases after park investments went into particular neighborhoods. So we could see the impact of those investments on neighborhood rents.
And Bonnie, we're going to need to wrap it up in just 30 seconds. So thank you.
Got it. Thanks. Okay, so just since we talked about reimagining the research university yesterday, I'll put a plug for a guidebook that's coming out next month, and you can see the website down there. And then this is just my final thoughts. So one, we need to quantify more benefits and co-benefits to recognize that all the methods we have are biased, but some are useful, and we need to embrace plurality in the methods we have. That economists have not cornered the market on rigor. There's actually a lot of really amazing work across a diverse set of social sciences that we can rely on. Obviously, need to adopt a systems approach, focus on process, not just products. Think about ways to scale the local, really consider who is the right person to decide, technocrats or people on the ground or policymakers, and of course, proceed with transparency and humility in all the work. And I'll stop there.
Thank you so much, Maya. That was fascinating. And up next, we've got Erin Mayfield, and please continue putting your questions in the chat so we can have a lively discussion at the end.
Great. Can you see my slides?
Yep, looks great.
Okay. Well, thanks, Natalie, and to all the previous panelists. And I feel very privileged to have the opportunity to engage today in the discussion. And so in the interest of time and also the desire to hear from others, I'll keep my remarks short and focus just on computational research gaps in terms of equitable deep decarbonization. I would say, however, my own research is very interdisciplinary and spans beyond computational and data-driven tools. And I strongly recognize the importance and also the complementarity of these types of insights that come from different qualitative and quantitative research, especially in this context. So to begin here, I conceptualize the research and societal questions related to equitable transitions in terms of the time horizon of the decisions and the impacts. And so in the very broadest of terms, there is the question of the past. So what were the procedural and distributional inequities of siting and operational decisions of energy and industrial infrastructure? And so more specifically, for example, things like what were the historical drivers of coal power plant or wind turbine siting decisions? How did race and income influence these siting decisions relative to other technological costs and political factors? Questions like what were the cumulative air and water pollution impacts from decades-long operations of industrial facilities? And so there are many computational tools and analyses in this space. And so these questions of history are addressed by well-established environmental justice tools like logistic regression, and in addition to newer analyses that some of the other panelists have showed that leverage the data and computational power that we now have. So answering these types of research questions of our past can contribute to understanding and decision-making regarding things like procedural and distributional justice, but also thinking about retributive justice as well. So moving to the present, the question is, what are the inequities embedded in our existing infrastructure systems, our energy industrial systems? And so, for example, what are the existing energy burdens on disadvantaged communities that other researchers on this call are experts on? Or how do different types of infrastructure, have they mediated air pollution impacts? And the last question is that of the future. So how do we design and deploy future energy and industrial infrastructure systems to meet not only cost and climate objectives, but also other societal objectives related to equity and justice? So I'll focus the rest of my presentation on this last question of how to employ computational tools that can inform decision-making regarding future energy transitions. So here's a conceptual model of a more common architecture of how we model and plan energy systems. So we begin with some type of energy system model that models at a national or regional or even a state level how a system can transition. So we're basically selecting a least cost set of technologies over time to achieve some climate target. And so there's an avalanche of studies that model least cost technology pathways to achieve climate targets. And a decade ago, I would have said, well, these energy systems optimization tools are largely academic. And while they may not embed the dimensionality and the messiness of the real world decision-making, they're not really used in actual decision-making. However, today, these optimization exercises are being used to inform and drive policy discourse, public policy, including past and pending federal legislation, and big investments in technologies. So in my opinion, it is becoming increasingly important to hold these energy system modeling tools to account, or more so the developers of these tools to critically evaluate the utility of these least cost models in real world contexts, where they're informing and potentially having a major influence on policy decisions. So that's kind of the first piece of this architecture, this macro energy systems modeling. The second piece is spatial planning, right, and infrastructure deployment. So at a more granular scale, how do we select the location of technologies based on least cost or other types of siting heuristics? And then the last piece of the modeling, if it's included at all, is equity and impact modeling. So we're determining the distributional impacts or the cumulative effects of decisions we make regarding technology and planning decisions that are based on cost and technology objectives, rather than equity and impacts being objectives in and of themselves. So I want to give a little bit more information on this type of modeling architecture that is typical in this space. So beginning with kind of this macro energy systems optimization model. So this figure shows electric power capacity over time in a business as usual case all the way to the left versus different pathways that each achieve net zero emissions target by mid-century. So for example, you can see alternative futures for gas across the different net zero pathways as indicated in gray. Structurally at high level, what we're really just selecting least cost pathways based on perfect information over a 30-year period to achieve some emission targets. And in reality, we know that transitions are much more complex than that, and it requires a large dose of humility to acknowledge what we can say using these models and what we really don't know. And so these models are not meant to be predictive. And so in my opinion, the purpose of these macro energy system models is really to clarify the contours of what could be and what we need to plan for, what the consequences of our choices are, what are the trade-offs, and how do we reduce transition risks. So we then use these macro energy system modeling output to model how infrastructure can be deployed. So in this example, we look at kind of solar, wind, and transmission. So this is a snapshot in 2020. So everywhere in blue is where we have existing wind. You can barely see it in orange, utility scale solar, and then transmission infrastructure in gray. And this is one example in 2050 of how things can be built out. We're meeting that net zero target. And this is just based, again, on least cost heuristics, where things could be cited given certain types of environmental constraints. In reality, there are multiple social and political and environmental factors and objectives and values that will shape how these infrastructure transitions manifest. So in the case of wind, for example, there are impacts on physical landscapes and ecosystems. There may be local opposition because of fossil fuel incumbency, potential for visual impacts, mistrust in our institutions. All of these things will influence how this infrastructure is cited. And this is just a look at solar, wind, and transmission, but we also model things like how do you transition thermal power plants and industrial facilities, build out CCS transmission infrastructure and biomass infrastructure, all of these different types of infrastructure that are going to be built out kind of in tandem or converted in tandem as this renewable infrastructure. And the third part of this typical modeling process is kind of evaluating impact. So what are the labor, the air quality implications, other types of socioeconomic implications of decisions that we make regarding cost and technology? So the question is, does this process reflect the way transition planning decisions will be made or even should be made? And I argue, and many other people argue, is that transitioning to a net zero energy system is inherently a multi-objective planning process, right? So it's not just based on some least cost objectives. There are political factors that come into play, the many different dimensions of social equity and justice that come into play, labor, air quality, climate, land use, all of these things are influencing how infrastructure will be deployed and the types of technologies we will deploy. And so I'm speaking to the choir a little bit here, but inequities are embedded in all of our existing carbon producing industrial and energy infrastructure systems. And so that means kind of when we're planning these future systems, it is the opportunity to upend a lot of the existing inequities, but we need kind of the computational tools and the planning tools to help us kind of plan these future systems. Also, a point of mention, there's a clustering of multi-source emissions in disadvantaged communities. So this is a map at the county level, so it's not particularly high spatial resolution of emissions. These are all point source emissions of greenhouse gas emissions, right? And then, as we know too, there's a clustering of emissions in disadvantaged communities. So this is just kind of keying into some areas, and you can see each of these bubbles represents a different industrial facility across different sectors, and the size of the bubble represents the amount of greenhouse gas emissions. And this is a snapshot in 2019. And across all these communities, you can see you have very high poverty rates, a high percentage of people of color, and this is kind of systemic. And we have many tools that show kind of the systemic inequities of where this type of infrastructure is cited. I'll also mention a large influencing factor here is the politics, right? And so local, state, and federal politics and power structures are influencing the decisions from siting wind turbines in a community all the way to federal infrastructure funding. And so this is just kind of one example. And so this is each dot in this map represents a different type of renewable infrastructure facility. And it shows the political polarity within associated with where each of those facilities are cited, right? So everywhere in dark red, you have a Republican supermajority. Everywhere in kind of that light blue, that's a Democratic majority. And I'll just note, solar, almost half of utility scale solar is cited in Republican and supermajority and majority districts, and almost 80% of our wind is cited in those districts as well. If you look to carbon producing infrastructure, 40% is within Republican majority or Republican supermajority counties. Another 30% is in Republican majority counties, right? And so fundamentally, our models don't incorporate these politics as well. So then that begs the question, can we move to a modeling framework that embodies multiple social, environmental, political, technical, and economic objectives and constraints, right? So baked into the decisions are these other objectives explicitly. Equity and justice are not outcomes of decisions we make about costs and technology. And I'll just note that, these types of tools, this is what I did my PhD on, this is what I've been building for a long time. There's other people working in this space as well. It's the frontier of research in some ways because we have the computational tools, we have the data to actually parameterize models to actually be able to optimize for these different types of objectives. I would say this is not new though, integrating multiple objectives into energy system and transition planning. We've done this historically, at least at a conceptual level. And this is just a snapshot of a report from Brookhaven National Lab in 1976, where they're looking at different objectives like facility costs, maximizing equity of plant distribution, minimizing population safety impact. A lot of the same concepts that we're talking about now. And so kind of in closing, some ideas regarding how the research community can meaningfully contribute to equitable deep decarbonization. The first, a national climate assessment of our historical and systemic inequities that are embedded in our industrial and energy infrastructure systems that's addressing both our procedural and distributional inequities of operational and siting decisions for each industry. We have the computational tools to do something like this. And I think it's needed. The second is state level assessments of the historical inequities that are embedded in our systems, and also the capacity of states to programmatically address inequities and equitably allocate things like federal funding and other resources. The third is a national to local scale long-term energy systems planning model that explicitly accounts for multiple objectives, including the many dimensions of equity and justice, much like what I was talking about in the previous slides. If we're going to be using these energy system planning tools in high-level decision making, then we need to invest more in these types of tools. And the fourth is, and this kind of echoes a lot of the discussion yesterday as well, a network of sustainable transition clinics at research institutions that can provide sustained analytical support for communities and local and state governments to inform both immediate term decisions, like how do you equitably distribute infrastructure bill money, to long-term decisions, right? So how to equitably transition industrial facilities, for example. And so this will also kind of build capacity through experiential education as well. And with that, I'll close and thank you.
Thank you so much, Erin. That was fascinating. And Ishan Nash will be our final panelist, and then we'll get to your burning questions in the chat.
Great, let me just share my screen. Okay, great. Can people see my screen?
Yep.
Okay, cool. Thanks so much for having me today. That was, I learned a ton from those first three panelists. That was really fascinating stuff. So I'm Ishan, I'm an economist, and I work with this group called the Climate Impact Lab, who's trying to understand the consequences of climate change at kind of a local level and in a very specific way around the world. And that's kind of what I'm going to talk about today. So this is a large research team we have that's a combination of economists and climate scientists and computer scientists. And what we're trying to do is try to use data from around the world to understand how the climate, how temperature and precipitation and storms and sea level rise affect people and how it's likely to change into the future, and how different populations all across the world and all across the US are likely to be vulnerable to those changes. So in terms of the motivation for what we're doing, historically, kind of at least in economics, the way we've represented the way that climate change affects society has been really at like a pretty coarse level. So a lot of the most prominent models in economics just kind of treat the entire world as one global agent without any different heterogeneity across different places, or have like really coarse large regions. And so we're trying to represent how global warming is likely to affect people at a much more granular level. So we make these estimates of the changes in the climate and the changes in how that affects people's lives at these much more granular, like county-sized regions across the world. So in terms of where this team sort of came from, originally parts of our research team worked on an effort to try to estimate the consequences of climate change across a few different ways, a variety of different ways in which it affects people's lives across different counties in the United States. And so Anna in the keynote was kind of bringing up some of the graphs from this analysis. And so I wasn't part of the team at this time, but a lot of the leaders of our team published this paper in Science about the economic consequences of climate change. And critically for the relevance of this panel today, a lot of what we did was try to estimate how that varies across different parts of the United States and across different populations, and how they might be differentially vulnerable. So in terms of the procedure for how we do this, the first thing we do is we gather lots of historical data on crop yields or on mortality or people dying from exposure to extreme temperatures and a variety of other outcomes. And then we analyze that data and to try to figure out how much are different populations vulnerable and how much are different populations adapted. So depending on what type of crop you're growing or where you're growing that crop or what the soil or precipitation conditions are, we can make some estimates of the impacts of temperature and of precipitation on those crop yields, or for outcome variables like people's health or how many people are vulnerable to dying from exposure to extreme climate conditions. We can try to figure out in the past for different populations like poorer and richer populations living in hotter or colder places who might be differentially adapted, how these conditions mattered. And then we use those to try to make some projections about how future changes in the climate using global climate models, how those might affect people's lives across the United States. And so this was kind of an initial analysis that we did a few years ago that was at the genesis of this research team that I'm kind of here representing today. And when we did that, we found, unsurprisingly, that some regions of the country, especially coastal regions and especially regions that are already hot as the world gets hotter, are likely to be differentially really vulnerable. And so this is a map from this initial set of estimates in that initial paper about kind of the welfare equivalent impact, or what is like the impact of all of these different ways that climate change is affecting people's lives if we kind of convert it into one standard metric, although of course there's some complications in how we think about how different people might be affected by these changes, as we've been talking about here. And when we did that, again, this is a graph that just kind of coincidentally Anna also put up in the introduction, but what we found is that poorer populations are much more vulnerable to these sort of extreme climate events. You know, just at kind of a high level, the poorest quartile of Americans are much less likely to have air conditioning installed in the places where they live. And so as we face more and more heat waves and dangers from extreme heat, they tend to be much more differentially vulnerable. And then similarly, there's a variety of other ways in which lower income populations and minority populations can be much more vulnerable to the impacts of global warming. Another thing that's kind of salient that's underlying some of what you see here in terms of the impacts being largest for the poorest parts of the population is like the budget share on food. For example, I know that's really salient right now with all the inflation that we're facing. The poorest quintile of Americans spend 27% of their income on food, compared to 7% of their income for the richest quintile of Americans. And so naturally, that's going to be something with agriculture as one of the more vulnerable sectors to global warming. That's going to be another way in which they're more vulnerable. So we've kind of tried to compile across all the different impacts of climate change and try to understand how are different people vulnerable within our country. And then that was kind of the initial genesis of this research team. And now we tried to expand that analysis all around the world to a variety of different ways in which this hotter, drier world, and drier in certain places and rising sea levels and things like that, how are those things likely to affect people all around the world? And so now we've got a new set of research papers that are trying to make these projections about the impacts of global warming on all of these different outcome variables at kind of a really granular scale across the world. So we can try to tell people, if you're living in South Carolina or if you're living in Mumbai, here's how much you can expect the sea level to rise. Here's kind of your vulnerability to increased storm intensity in the future. If you're living in a certain place, how hot is it likely to get? So that's kind of what this research has told us. And we've been kind of deep in the academic weeds of trying to write these papers and make them rigorous and make them publishable and make sure that we're doing things right. And now we're sort of at the stage where we've been transitioning over the last year or two into trying to make the results from this research as accessible as possible to the public and to decision makers and to people who are trying to understand how to be informed about these issues. So one thing we've done is partnered with some news organizations to make these kind of interactive maps of, for each different place in the United States, how much can we expect over the next 10 years, over the next 25 years, over the next 50 years? How much can we expect sea level to rise in your community? How much can we expect humidity and temperature to change? And then what are the impacts of that? Suppose you're a farmer, suppose you're a policymaker trying to understand what's going to happen in your community. How are these climate changes mapping into changes in economic variables that we think we can measure? And so as part of that, there was like a New York Times interactive as like one example of the types of ways that our team has tried to make this data available. I'm just kind of on the nerdy academic side, but we have other people who know how to do these things and try to make this stuff available to the public. And so in the New York Times, there's this interactive that was like, how much hotter is your hometown now than when you were born? And how much hotter is it likely to be later on in your life and later on in your children's lives? So we're trying to make climate change a more concrete, understandable thing of how is this actually affecting people's lives to try to hopefully help people prepare a little better. So you can go on our website, impactlab.org, if you're interested, and we have some interactives where you can try to answer questions like this, and we're adding to these fairly rapidly at the moment and over the next few months and hopefully a few years. But for example, you can click on your community and look at what are the number of days over 95 degrees Fahrenheit that we faced historically. I'm from Chicago, and so that's probably where I would click on this map. How hot, how much extreme heat do we face when I was a kid there? How much are we facing now? How much might we face by the time my own children are my age? Things like that. So these are the tools we're starting to try to make available more and more. And then to add to that, it's kind of, we can add like, what are the ways in which this extreme heat or the droughts we might expect to see in the West, how might that affect some of the variables that are more concretely impacting people's lives? And then another sort of new thing that our research team has been working on is kind of more directly targeted, trying to use our data to inform decision makers and inform policymakers. So this is just one example. We partnered with some of our colleagues to write a report about New Jersey's vulnerability to rising sea levels and to storms, to try to help people understand in like a really concrete way, how can we protect our coastal communities? What types of flooding are they likely to face? And what places are they likely to face flooding? And things like that. And then another thing we're doing that I think is maybe a little bit less relevant today, but is worth mentioning briefly, is we're building out this platform where for some of this federal government regulatory impact analysis, you might want to measure something like the social cost of carbon if you're trying to do cost benefit analysis, subject to the excellent points that people made earlier in this panel about the complications when you're doing cost benefit analysis that are really important for us to think about. But we've tried to let people understand, okay, suppose you want to choose your own adventure, how much emissions is the world going to put out over the next few decades? How much richer is the world likely to get? How much do we think those emissions are likely to impact the global climate based on these climate models? And how do we think that's going to cost our kind of global community? So we're trying to make these tools available just to make sure that the data that we've tried to work on and tried to create and the evidence, the pile of evidence that we've been working on making over these last few years is accessible as possible to these public audiences. And as we continue to try to do that, we're also partnering, this might be relevant to some of the people on this call in case there's something that you're working on that you think could be interesting to partner with our group on, or that you think that the scientists and computer scientists and economists on our team might be able to help with. We're starting increasingly to partner with these public-facing institutions. So here we worked with the International Rescue Committee to try to highlight what are some of the places in the world where we think the climate conditions might be likely in the coming years to contribute to sort of political instability, or what are some places we might worry about severe climate events really being dangerous and risking destabilizing people's societies. And then similarly, we have another burgeoning or kind of budding partnership, I guess I should say, with the United Nations Development Program, trying to understand how our populations at a local level around the world, what are the changes in the climate conditions they're likely to face? How's that likely to affect the economy, people's labor productivity, how much energy people are consuming, the risks to people's health and things like that. And so we're increasingly trying to get into more of these policy collaborations. And so that's just kind of trying to give you a flavor of this research team that I've been very lucky to work on, and what our colleagues are kind of involved with. And I just wanted to say, you know, there's some other groups within economics that are also doing some great work, and I wanted to mention those quickly. So there's the Environmental Inequality Lab that I have some friends and colleagues who work on, and they've got some of their own resources. And there's another group at UC Santa Barbara that some of my colleagues, including from the Climate Impact Lab, participate with, called the M Lab, and they have some of their own interactive tools and resources that could be useful. And so there's a number of these different things starting to emerge in economics, and we're trying to, hopefully some of us are trying to make this as accessible beyond the academic community as possible. But I just wanted to give like a bit of an overview of the Climate Impact Lab today, or that's sort of what Anna asked me to do on this panel. And so hopefully that sparked some thought, and hopefully you have some ideas for other ways that in the future we could make our work more relevant and impactful for the public facing uses and purposes that all the people on this panel seem to have been doing amazing things for. So it's a real joy to be here, and I've been really privileged to learn from other people's presentations as well, and I'm looking forward to the Q&A.
Thank you so much, Ishan. And just as a heads up, we have a 15-minute break after this scheduled time slot, so we'll plan to go over a little bit since we got a bit of a later start. Thank you so much to all the panelists. That was really fascinating. I'm going to try to start with the beginning of our session and tie some of these questions together, but continue putting your questions into the Q&A. So thinking for Susan and Ishan particularly, we had some kind of questions and feedback that Noel and Luis put into the chat about incorporating community priorities into the research. So something that Bonnie's presentation made very clear and Luis made clear is maybe the research priorities and questions are different between what we think we should be looking at and what communities want us as analysts to be looking at. So Susan and Ishan, if you could speak a little bit to how, if any way, communities were involved in the process of like using satellite imagery or defining the research questions for the Climate Impact Lab, what that process was like.
Sure, thank you for the question. I'll start. So satellite data is, I would say, a challenge and an opportunity. So one of the challenges is that it's a little bit more difficult to work with than community-based participatory research monitoring, for example, that might be happening in certain cities or neighborhoods. Satellite data exist on NASA servers in NetCDF format that typically require that they're there with sort of spatial swaths, not the entire world. Each file is maybe an hour or a daily snapshot. It requires still technical work to translate that into something meaningful for people. And so that is what we're starting with. We're still in early days here. We're starting to try to work with those data and flip them into a format that can actually be used by the EJ mapping tools or by community groups. So that's sort of the stage where we're at. We do need to look for ways that community groups can participate in the development of the data and making it accessible. We've been working on things like story maps or GIS files and how-to documents to make it easier for community groups to be able to work with this. But I would say it's really an opportunity. We can't, we can't only use satellite data. It has its own challenges. And I would argue pretty strongly that we can't also only use ground monitoring data because it is too sparsely, the coverage is too sparse. So we need multiple data sources and we need to integrate them. The good news is that there's a lot happening within the government to bring researchers and community groups together to be able to work with this type of data. There's a NASA solicitation out now that that proposals are due in November that requires people to work with community organizations and that they be funded on the grant. And that's not the first time NASA has done this. They had one that closed several months ago also that had that same requirement. EPA is doing the same. So I think that in the coming months, we'll see a lot more integration between the scientific data from satellites and the community group engagement. Thank you.
Do you want to add anything to that, Ishan?
Yeah, I mean, I guess from my perspective, I think this is kind of like the next step for our team. I think we were starting out from an economics literature that had the world zoomed out, like you were staring from, from Mars at the Earth, and it was like this one planet with not different people on it. And I think we've tried to use a little bit more granular data, and especially like the advances in computing power to start to understand, to start to make progress, at least in our economics world, on understanding how different communities, what the challenges might be at sort of a high level. And I think the next thing is how to bring that data and academic work more into ways that are useful for those communities. And so I think we're kind of just at the beginning of that sort of process. And so I don't really have like a lot to add about that, but hopefully that's like a goal for the future, I think.
Thank you both. I hope that was helpful for the attendees. Another thing that's come up mostly for you, Erin and Ishan, is thinking about with these multi-objective optimization projects and models, how do we think about common units and decision-making? So we had some conversation yesterday and today about, we have all this information, but how do you decide which areas to prioritize? We need a framework to decide, given some limited budget, what are the locations that most need that money? And so could you talk a little bit more about how you translate different metrics into a single unit? And then also, if you have considered equity weighting or the use of equity weighting, if you could define that a little bit for the audience as well.
I'm actually going to connect the question you posed before to this one, right? In part is trying to understand the dimensions of equity that are relevant to a given community, right? So that could be through kind of informal engagement, through surveys, through interviews, right? To understand the dimensions of equity that are relevant, then we can operationalize them into a model, right, to the relevant dimensions. And then there's dimensionality reduction. If you make a decision and you have two different objectives, but they lead you to the same decision point, then some of those objectives aren't actually relevant in a modeling framework, right? We can reduce kind of the complexity of the model. We're never looking at kind of, or at least in what I do, I'm never looking at kind of a single objective or a single metric. You can roll everything up into many things up into monetized forms, but you can also keep it into its physical units as well, right? So we can talk about minimizing premature mortalities on low-income communities. We can talk about kind of maximizing the equitable distribution of jobs in terms of physical units that people understand. We can talk about trade-offs between these different objectives. Rather, we're not picking one future net zero pathway. Rather, this is kind of the suite of pathways, the suite of decisions that we can make in the trade-off space for those decisions.
Yeah, I guess from my perspective, I think this is like really critical in my little economics world that I live in when we try to calculate the cost of climate change. It's like such an enormously quantitatively relevant feature of climate change that people who are poorer bear the overwhelming share of the costs. And so if you do kind of I think I forgot whose slides those were, maybe Bonnie's, where you're talking about in cost benefit analysis, there's like an assumption that you just want to maximize the amount of dollars and assume that people will transfer money to the poorer people, or kind of assume that if you maximize the amount of dollars, that'll map into maximizing welfare. I think that's like my view, is that really doesn't hold in the long run. So I think we really care a lot more about costs that affect poorer populations. And so one of the things we've done in our climate change cost benefit analysis is try to explicitly account for that. And so we're just kind of applying a simple concept from economics, which is like we observe that people are risk averse. And so people are willing to pay to avoid situations where they're losing in catastrophic outcomes. Like people buy insurance on their homes in case they burn down, even though on average you're going to lose money from buying that, because when home insurance pays off, it's when your home burned down and you're in a really bad state of the world. And so what that implies is that in a bad state of the world, or when you're born into a tougher situation and you're poorer, each dollar is more valuable to that person. So the way we've tried to value climate damages in our analysis is to value them from the perspective of someone who doesn't know who they are in society. And so we're basically applying that concept of risk aversion across people. Like you might be born into a poorer neighborhood or to a poorer family, and then each dollar of climate damages that you're suffering is going to be worth a lot more to kind of what we might think of as social welfare than if you're Bill Gates. And so we think that's like super critical, basically, we're forced to do cost benefit analysis about climate change, at least in certain contexts. Like the federal government calculates benefits and costs from climate regulations, and a lot of different organizations and entities and governments do around the world. But if we're going to do that, I think it's important that we try to use a concept of welfare that's like rooted in at least some sort of conception of justice. So yeah, I agree. Basically, that was a rambling way of agreeing.
Thanks, Ishan. And kind of bringing it back to the previous question. So we're talking about data. There's kind of, there's many dimensions. One is sharing your results and sharing the kind of underlying information. It sounds like there's a lot of maybe a strong pipeline at the Climate Impact Lab and in your research, Susan, to disseminate that information, and that's a goal. And I guess, what is the kind of goal for incorporating community voices into that development of the research questions? So bringing Luis's question back into the room a little bit, maybe I paraphrased it poorly the first time, but what is the need to do this research compared to what communities have been defining as their priorities for decades, if not centuries in some cases. And so how are those voices being brought into this conversation with your research?
I just have a quick reaction to that, and other people can say more substantive things. But I think for me, I feel really conflicted about that. I think I would be fortunately, I'm like super junior and don't have to do any fundraising, but I think I'd be a terrible research fundraiser, because if people ask me why should they give money to my research, I'd just be like, you should give money to poor people, actually. And so I think it's like it makes me feel conflicted about the work that I do. Fortunately, most of the work I do is pretty low cost in economics, but I think it's like something we should be thinking about all the time, is like, is this actually better than, like, is what we're doing with our money and resources that we're taking for research actually better than like direct improvements that we could make with the same money?
Thanks for that reaction. Any other panelists want to respond to that?
I guess I'll offer a few more thoughts, because I think originally the question was posed to me and I probably completely misinterpreted the question, so I apologize. I think both are really needed. We need data that has full geographical coverage, and we need local knowledge to work together. And frankly, it's messy. When we work with satellite nitrogen dioxide, we're seeing different neighborhoods pop out as being overburdened, depending on the data set that we use and depending on what communities and governments tell us. And we're not yet in a space where every piece of information points to the same problem. And maybe we'll get there, but we're right now, I think, still swimming in different types of indicators and different knowledge from different places. And it's challenging to figure out what to do with messy data that point in different directions. But that's why we need all the voices in the room to make sure that we're making decisions that are informed and bringing all of the information in together.
Can I also chime in on this? So I started my career as a practitioner in environmental science in the field, doing hazardous waste site remediation in places that are now considered overburdened communities. The people in the communities knew they were overburdened. They know the impacts. They can tell you the stories. And from working in all of these communities, I could start to see it systemically too, right? And that's why I transitioned into research and building computational tools, because I knew the regulations and the tools that we have are inappropriate, right? But that is where the power also lies in a lot of these discussions. So I think there kind of is complementary value kind of in all of these types of things, both these computational tools that further kind of support what the lived experiences of people.
Thanks, Erin. And I know we're already 5 minutes over, so we're going to have a pretty short break. And I'd like to just close with a round robin for all the panelists to answer in 1 or 2 sentences what you consider to be the primary barrier to improving research with the focus on equity, Justice40, distributional analyses. Just the top priority.
I'll just offer a first thought is that just piggybacking on my last answer, disparate data sources that have different resolutions, different geographical coverages, maybe there are actually different indicators and local knowledge, and bringing that all together in the same framework is still a major challenge, and one that I'm excited for this community to work towards resolving.
Erin, Bonnie, Ishan?
I'm actually going to borrow something that was in Dr. Keeler's presentation, which is also how I see it, focusing more on process than products. She put it perfectly there. And I think that for in my vantage in an academic institution is the thinking about kind of the process or helping decision making in real time and developing venues for that, like sustainable transition clinics where there's kind of experiential education, but we're also helping informing decision making and supporting decision making in real time for our communities.
Thank you. Ishan, Bonnie?
I have about 12, but I'll just say that one of the things that I'm thinking about right now is what's the role of us as educators. You know, this isn't about the research, and it's more about how are we training the future leaders to address these problems. And the training that we got as academics isn't fit to purpose with the kind of work that we're talking about today. So how are we really rethinking the academic models that train researchers to do work that's relational, that's engaged, that's, you know, acknowledges cultural competency and historical context. And that's a very different kind of training. And we have a long way to go to really meet the challenge that requires.
Final word, Ishan?
This is not profound enough to be a final word, and definitely not the most important thing. But I mean, I think one thing that's really hard for me is like when you're a super young academic and you're trying to get a job and get tenure, like you need to publish in these journals and they don't care if your work is making an impact in the world. So anytime you spend trying to make your work impactful is basically like the thing that is taking away from your probability of like getting to keep doing the job that you like doing. And so in that sense, I don't think academia is really structured in a way to make these things like community accessible and community facing.
That is a profound note to end on. We've got our own misaligned incentives within the research community, and of course, many more in the system that we're working in. So we'll have to end there. We've only got about 6 minutes till the next panel. So go get some coffee and bathroom break, and we'll see you back here shortly. Thank you, panelists, again. That was great.